All right. So when we first did this recording, we had a bit of a technical issue. So it's actually two recordings cut together. You may spot a few differences as we go through. So apologies for that, but hopefully it doesn't alter the content at all. So this presentation is a journey into Azure DevOps. We say a journey because we are not done with our experience with Azure DevOps, and we're certainly not don't consider ourselves experts in Azure DevOps necessarily. So you may see things that are you would do a different way, or maybe you think it could be configured better. I mean, that might be the case. Feel free to let us know. We would love to carry on improving our implementation in Azure DevOps. So who are we? My name is Tim Wheeler. I'm the head of engineering services at SquaredUp, and with me is Shaz, one of our DevOps engineers. Hi, Shaz.
Hello.
How you doing?
Good, thank you. How are you?
I'm very well, thanks. So a quick agenda of what we're going to run through today. So we start with what our setup was like before we moved to Azure DevOps. And then we're going to do a demo, a bit of a walkthrough in Azure DevOps of our current setup. And then we want to go through three issues that we kind of came across that we had to come up with different solutions for, which we think tackle different problems, and hopefully you'll find those interesting. And then finally, we rounded out with some questions from those that have been watching. Okay, so DevOps BS. Well, before Shaz, obviously, is what I mean by BS. This diagram, I'm not going to walk through all of it, but this was a diagram that I put together when I first started looking at our DevOps setup. And it's fair to say it was, not given a lot of attention at that time. And it's, if you look around the diagram, there's a lot of third-party tools. We've got 2 instances of Jenkins. We start from Bitbucket as a code source. We've got Octopus Deploy. We've got TestRail in there. We've got Browser Stack. We also had JFrog Artifactory on there as well, which is not on that diagram. And the reason for this is because no one had the full-time job of looking after this. It was very much something that was done on the side, or something breaks. Can you just do this? Can you just make that bit work? And so I've captured a few of the thoughts that people had back in the day when they were using our DevOps stack. So who owns this? Who's got access to this? I hate it. This starts working if I keep restarting it enough. I mean, I'm sure a lot of us have seen systems like that. It's fair to say it wasn't very well loved, and it wasn't given much love in its defense. So what did we do? We decided to start with a clean slate. We moved to Azure DevOps because we weren't using it at all, so it seemed like a nice way of starting again. We were already invested in Azure, using a lot of services at that point, and we had some in-house knowledge of Azure DevOps. And it was already, widely used, which is a real benefit when you're trying to get examples of things and trying to get yourself started. It's there is that benefit of not being on the bleeding edge of new software. So, with all that said and done, Shaz, you're going to give us a quick tour of our setup.
Yep. Thank you, Tim. Well, we'll first start with our server product, which consists of our SquaredUp for SCOM, SquaredUp Azure Edition, and Community Edition. So, just to begin with, we do use a variant of multi-stage pipeline on this as well. So it starts with the pre-build stage, and then that progresses onto 3 different products build. Now, these are completely based on YAMLs. So they are all source controlled. They essentially use a template in the background to run all of these 3 jobs within these stages. So moving on to away from this actually progresses into a release pipeline. Just to show you guys what our release pipeline looks like, starting from, I was just going to zoom out just a bit just to show the full set of it. So just to just a quick run through of it, these are sort of like dependencies when they're highlighted. So they progress onto from one stage to another stage to sort of like another stage.
And is that why they're in 3 columns to show those dependencies
Yeah,
at
exactly.
high level?
Yeah. And then when you sort of like click on the stage as well, it shows you where that's what those are dependent on. We have different tasks as where we deploy into user boxes. We'd mentioned we were using Octopus Deploy in our previous sort of diagram as well, and that's now moved across to deployment groups. Deployment groups essentially are just set off sort of like a pool of VMs. For our instance, we can say here we've got 5 different VMs on this deployment group. The benefit of using it this way is you can see almost all of your deployment history on it. Apart from that, going back to the release itself, we also have these release stages. They consist of task groups. The reason that we use task groups is that so that we don't have to use the same job over and over again. Just looking at example 1 here, let's just take a quick look as one of these right here. So this consists of 3 different steps in this task. Now, if we look at the references to it, this has been referenced to several stages in here. We do have production and pre-production in there, which is mainly just to show it's not actually going into pre-prod and prod environment. It's more for when I do sort of like maintenance work on it, like I first do it on the pre-production pipeline and then take it towards production.
Yeah, so our pipeline goes through all the environments in one pipeline,
exactly,
as opposed to having a pipeline per environment.
Yeah, exactly. So that's mainly our task groups in here. So this is one flavor where we sort of have utilized both pipelines and releases into it.
And sorry, just before you move on task groups, so that means that where it references all those places, if you didn't have task groups, you'd have to edit it.
Yeah,
it's like I don't know how many times that was, but a lot.
Yeah. As you can see from here, it makes that really hard because then you sort of have to know where each stage is if you have it, and it's very likely that you're gonna miss one of those stages, right? And then that means like it could cause a lot of problems just to figure out where it was. So meaning when you have it from here, I can just go into one of these and just modify it in one place, and it's all done in the entire release pipeline has that. So that's the main benefit of using task group. Moving on into a different flavor of pipeline. So what we've done here for our upcoming product is we've used full multi-stage pipeline on this one over here. So this progresses all the way from the client and API, sort of like the build to deploying to production and into smoke test. However, in this one, there is quite a few skipped stages in there. Now, these are conditional stages. That's why they sort of had the skipped. What we use here is sort of like, different type of branching, such as work or master branch. So for production and pre-production environment, only those master branch and, just master branch goes through to it. Just look at what it looks like for a master branch run. That's what it sort of goes from, sort of like all the way from build towards production, and then it's test against that deployed version. Now these are conditional as well. We've got like a validation in between, sort of just to make sure not every every deployment goes into production, right? So we use 2 different techniques for it. So we have branch control and we need approval. So branch control is where you set that the master branch can only deploy to it, and then approval is just have one of your, someone in that department to control that. So what they get is usually like a Slack message where they can approve it or reject that stage. Now this is also source controlled, meaning everything going in is checked before it goes through. This doesn't require a pre-production and production pipeline because it's just affecting your branch. I can just branch off it, make my changes, and it will just affect me rather than just affecting everyone. So we haven't used the pipeline pre-production and production into this one. We just use the actual deploying to pre-prod environment and production environments. These are actual production and pre-prod environments in here. That's mainly our different type of pipeline, multi-stage pipeline.
Are there any other advantages to having this sort of multi-stage pipeline versus the other setup?
Yeah, so there's less clicks because that's one of the complaints that you get from a lot is, people you got to go from pipeline to releases. You can also see everything under one roof. You can have all your test results in one place. It just makes it so much easier, just viewing everything in one place, I suppose, compared to just having to navigate through releases and pipelines. These are stricter as well, that I can't trigger these stages or anything like that if they've been skipped. Whereas on a release pipeline, if it's skipped, you can still trigger it. So there is that as well. Yeah, and yeah, I'd say that's the main benefit of sort of like moving towards multi-stage pipeline.
Makes sense. So yeah, that's a very brief overview of the types of pipelines that we've got set up in Azure DevOps. And I suppose one thing to add as well is that all of this has helped us take out those third-party tools. Yeah. So you've now got one portal you go to and you work from that.
Yeah, exactly. Essentially, we get sort of away from a lot of it and then just bring it into one place.
Okay, so now we're going to talk about a couple of those specific solutions we've built to overcome some issues. So creating redundancy with agents. I mean, the situation that we found ourselves in was we have a big release due and suddenly everything stops working. We start getting these queues building up. We get this severity unhealthy from pipelines. And that, I mean, the screenshot's quite small there, but it says pipelines in your region may be impacted by a live site incident, resulting in possible pipeline delays, which means nothing's working, quite simply. And obviously, when we're building up to a release, there's marketing to consider. There's all sorts of comms, live webinar on top of everything that engineering's trying to do. So this is not exactly an ideal scenario. And we did find a workaround, which you're going to demo in a sec, Shaz. But beyond that, we also wanted a way of very quickly switching away from Microsoft agents, which was sort of the underlying problem here. So I think, Shaz, are you doing is it on the next slide or is it a demo? It's a demo.
Yep. So so as we were first, when we started with Azure, DevOps, one of the first things that we noticed was using the Azure hosted was much simpler than having to use self-hosted, because you have less overhead. Sort of depending on your setup, it could be a less cost as well. So when we first ran into that problem, what I essentially had to do at the time was to create a create self-hosted agents at the time. So one by one, I had to create multiple agents, run multiple configuration on them in order to have them as Azure DevOps agents. And one thing I sort of realized was like it's not always useful to have that, because you sort of lose like the track of how many VMs you want to turn up, or what sort of tools that you've got it installed. So when we first looked into it, as I was, I discovered just as I was creating self-hosted agents, was like when I was adding a pool, I saw that you could create a Azure virtual machine skill set, Azure DevOps agents. So then just quick overview, there was really nice documentation on how you create that self-hosted skill set agents, and then essentially just following based on that, what I then did was I created a skill set agents, and then sort of based on that, and then you come into here and then you sort of decide what sort of settings that you want for your skill set agents. Just looking at this one, and then based on our uses. So what we had to do on this one in this case is like here we wanted the maximum number of virtual machines in the skill set to be 13. We always wanted 1 on standby, and then we wanted the agents to be deleted after they've been idle for 3 minutes. And the reason to sort of set your maximum amount could be that you want to have the same amount of VMs as similar to your parallel jobs, because if you have more than that, kind of defeat the purpose of creating it, because you will just have VMs running up and then just cost coming up. There's a really good thing is you can also see how they've been scaled. You can see, at the live view from it, you can see that they scale in, they re-image when they're done. Now this was based on a image. So our image is completely based on how Azure pipelines are configured, Microsoft agents are configured. So what the repository that maintains that pipeline is actually public. So once you discover that, sort of you could see the images and what they were installing. Now, if you're really familiar with Packer, it's really easy to get onto it. It's sort of just understanding it, modifying these based on your needs, and then just creating an image completely from that. So once you have that, you can sort of like integrate with this one as well. And then every time there's a new image, there's a new one deployed to your environment as well. So yeah, that's how that was our solution in order to tackle that problem, to have at least something as a backup plan when Microsoft Agents goes down.
Yeah, so with those details you've just shown there,
yeah.
You've effectively got a copy of exactly what Microsoft are doing.
Exactly, yeah.
But you're able to host it yourself.
Yeah.
And what are the steps to kind of switch over if there's an outage?
So like I mentioned, we do use YAML in our pipelines. And what we've done is when we create the YAML, you get to define what sort of agent pool and image you're using. What we've done is we've actually created that as a variable. So when that's been created as a variable, you can go into it and sort of modify that, create a variable group, have those variables that you've set, and then sort of just modify that. So for this one, let's say if I want to switch from Azure pipelines because they've gone down, or I need to do some work on that side, all I need to do is I just go on the agent pool that I have, get the name of it, go back to the library, variable group, and yeah, that's all we do is save there. Just to clear out variable groups are just a set of variables that you can keep it. Sort of like, you might have secure variables that you need to lock that, so no one has access to it. Azure DevOps do nicely sort of like hide that away from it as well. So it's quite hard to actually retrieve that.
Mm-hmm.
And we sort of use that to control the agents from one to another.
Yeah, and so with that, it's just a couple of clicks away to recover from an outage.
Exactly, yeah. And once you know the status is back up, you can go back to it, switch back to Azure pipelines.
Excellent. All right, if we go back to the slide deck, thank you very much. So that was scenario 1 or solution 1. So solution 2, bringing out automation testing in-house. Now, this definitely has some pros and cons, but in the scenario that we were in, we were using Browser Stack to kind of orchestrate our end-to-end automation tests. Now, Browser Stack is a very fine tool. But we had a few issues with it, just with our setup. So speed was a problem with the total time that tests took to run. Cost, the way their licensing model works, meant that when you say how many, they call it parallel threads, so the number of agents that you're going to have running tests is set up, you always have to go for the maximum number that you're ever going to use, whereas we found that we're very much operating in a sort of peaks and troughs as we go through a release. And then dashboards. So being a dashboarding company, we are very fussy about what a good dashboard is. So we weren't so happy with their reporting on that side. And finally, their architecture, which actually feeds back into the speed issue that we had. So the fact that this diagram at the bottom left that we're showing there is showing you for effectively one set of commands, you have got to trigger it from our side in ADO. Then we'll be passing that over to the Browser Stack server that would then spin up another VM, pass those instructions over to the VM to do the testing, and then it all passes back. So when you're trying to decipher like where the lag is, or how you speed up tests, that becomes that becomes quite hard. And we don't have access to the Browser Stack setup, obviously, so we have limited control. So we thought we would take control and bring it all in-house ourselves. So yeah, Shaz, do you want to walk us through what we did?
So what we first started with was let's create a simple architecture, because if you look at this diagram here, what it's essentially doing is each test has multiple commands, and it's all going from your network to Browser Stack Secure Cloud. And with each command, there's always a delay. So what we did was we just thought, let's sort of like simplify this. And the approach we took was remove that completely. So what we then ended up with was a virtual machines, multiple virtual machines that would replicate user VMs, user machines. So when a SquaredUp user is talking to a SquaredUp server. And then we had multiple servers that were acting as SquaredUp host. And each command in here are being processed from the agent straight to the host. What was the result? So the result that came back to us was amazing, because in our first instance, we was able to get sort of a really good run of a test. So in the first picture, the test duration was about 1 hour, 12 minutes for the similar test, which had about 453 tests executed, and that took about 1 hour and 12 minutes. And then when we ran that in our new setup, we were able to bring that down to 25 minutes, almost 25 minutes, 26 seconds, you can say that, and has less failure rates as well. So we had a good run with that. We've also done video recording. Now, one of the browser stack's really useful feature is that it has video recording. So in order to bring that as well and not miss away from that feature, because it's really useful that when you need to sort of like diagnose a test, watching a recording makes it so much easier for you to do that. What users who trigger their test usually get a Slack message that would say, your test has completed, and then there's a result of that test run, and they also get a link to then watch the recording as well. Moving on from that, we also, one of the main thing with agents, sort of like utilization of our automation stack, was with Browser Stack, we were kind of limited on how many agents that we can have, as in we couldn't be flexible during the time and then say, because in our dev phase that we have multiple phases, there might be a phase where there's less automation tests running on, and there's definitely a phase where there'll be a lot more automation tests going on, especially during the release time, right? And that doesn't help, because sometimes you would literally max out all the way from like your running agents as well as your queue. Well, in Browser Stack word, that would be threads. So we would run out from the Browser Stack thread for running as well as queue. So that would be 20 like threads completely maxed out, and then it would literally just throw any other test coming through, it would just like fail those, it would error those out. With this, what we've done is we're hosting agents in house, so we can sort of decide on to how many agents we can have during what time. So during different phases, especially during release phase, we can have all of them powered on or create more and sort of run them all at all time, whereas other times we can sort of like have less agents based on what's going on. And it really helps us to save cost as well, because we've got different schedules on them that allows us to shut them down when they're not being used, and they start up sort of like in the morning and shut down sort of like evening time as well.
Yeah, so we can tailor it to the hours that we know engineers are most going to be using.
Exactly. Yeah, and that's proven helpful so far.
Very good. And if I'm right, we Slack people the link, right, to their recording, and they can watch it live.
Yeah, so what we do is before the test starts, the Slack messages are technically PowerShell scripts sending those Slack web API calls. And what it does is before a test starts, it sends them a Slack message saying your test has been triggered for this test suite, and you can watch that live by sort of using VNC. So what we've done is we've installed VNC on those agents, and then users can actually like VNC view to that server that the test is running on.
Yeah, I mean, that's great. I don't know how useful that is, but it's fun to know they can do it.
Yeah, sometimes you want to watch live, right?
Yeah. All right, cool. So that's the how we brought automation in-house. Okay, and then our final solution that we wanted to go through was publishing to the Azure Marketplace. So I think we had that up on screen before in the first demo that Shaz did. So the end state of our pipelines. It's all right. Stay on the slides for a sec. I'm going to go through these points. That's fine. Yeah. So it's the end stage of our pipelines. Part of the continuous delivery journey. And I think one of the things that's maybe not well understood is in Azure DevOps, it doesn't have direct integration to Azure Marketplace. So Partner Center is the sort of back end of Azure Marketplace, and you have to set it up there and understand Partner Center before you can publish things to the marketplace. Do you want to just, show the marketplace screen? Sorry, there we go. There's our lovely product, SquaredUp Community Edition, in the marketplace. So yeah, so we really wanted to bring this into our pipelines as well and automate that, because Partner Center, as I mentioned, is its own thing. It's its own portal. So you have to learn how to publish through that. It's also a lot of manual steps. There's a lot of options in there. So, it's the sort of thing that's prime for automation. Once you understand what you're doing, you're not going to do it every day, so you might forget. And also, just from a speed point of view, you want to know that it's going to do exactly the same thing over and over again for you. So how did we do it, though? If there's no integration, Shaz, surely it's a miracle.
Yeah, so what we had to then do was so in order to publish your image in the Partner Center, what our offer is based on Azure Virtual Machine. So in order to do that, you need to provide Partner Center with a base image. Now, in order to create that base image, what we use is Packer, and Packer sort of creates like a base image of SquaredUp being installed, a few configurations done, and then stores it to a storage account. Then we have PowerShell scripts that runs that to create SaaS URIs. SaaS URIs are essentially the URLs that you need in order to access those VHDs. And then we use the Marketplace API to sort of place that URI to the offer, and then it's done in the Marketplace. Now, this has a lot of benefits, especially around speed, like Tim mentioned as well. Mm-hmm. And, doing each of these is through ADO makes it really useful for us. If I could just show it, what we have it as. Let's go back to the screen. And so what we have is a stage in Azure DevOps as well. So the release stage going back to the release pipeline, and this has a stage that publishes it to the marketplace. We also have gated deployments. So these are it's required in order to sort of create that deployment. Unless that you have met the requirements, because through ADO you can see that these lines actually means that they're the requirements in order to be sort of those stages need to run in order to run that stage.
So they're all the dependencies.
Dependencies, yeah. That's why they're sort of in like 3 different columns right here. Sort of like what's dependent on what. So if there's a line going on from one stage to another, that's essentially saying, hey, that's in order to run that stage, it's most likely that that stage needs to run as well. So the Packer build is actually done in the previous stage in here, and then it progresses onto the marketplace stage, which is then dependent on the end-to-end test for that sort of marketplace product. And so what usually happens during the release phase is that Tim would get an email or a Slack message that he has to approve it in order for it to go to public. And when he's done that, he gets that. So for this instance, I'll just do it myself. This is usually not everyone can do that, so that you have to be release admin in order to do that.
To do the override, you mean?
Yeah, to do the overrides, because sometimes there might be a case where one or both of you not here, so someone else has to sort of like do that. And then based on that, what we can do is we can improve from here. Actually, let's improve that one here as we're talking about it. Why not? And then it's nice to show that I've approved on behalf of Tim, and we can actually see the stage actually being triggered in here. Now, this sort of like consists the PowerShell script that I mentioned earlier. They're actually being called as part of the jobs in here, and it's calling a function that's written in PowerShell and sort of like calls them in different calls them all at once, and then suddenly it's there in the Partner Center portal, and that's all done for you.
Marvelous.
I think that's
one more slide. Oh no, we did demo. And that's the last solution. So thank you very much for listening. Thank you, Shaz. And any questions, anything people want to ask us, or go back over. I know some of that was potentially quite rapid, depending on how well you know Azure DevOps. So any questions? Okay, got a question popped up from Darren about Packer. So can you show some of the detail around Packer?
Well, so
no pressure. Just do this live.
All right, so let's go follow up on this. Packer is obviously, so depending on what sort of Packer you're talking about here, let's look at the one that we've used to create our agents, the self-hosted agents. Now, if we was to look at this is a bit scary one, it has a lot of information that you need. So what it is you need to define, this works with different cloud, so you can have, for Azure, you can have for GCP, you can have it for AWS as well. And what it is sort of a file that would say, what it needs to do for the VM to sort of create like an image for you. So let's say for this one, what it has is like builders. So these are what it's required in that sort of, so say this one is built for Azure. So these are sort of like the builders that you need. So this covers
You might want to zoom in just a little.
It covers mainly around the client ID, client secret. This is needed in order to talk to your Azure tenant, and you also get to define. So this one here defines like the base image, what you want it to have it installed with. You can have multiple different OS running on it, and then what then you do is you create provisioners. These are now an array of different steps that you'd run. So there's different types of provisioners. Let's say a PowerShell. So what you can do is PowerShell sort of to run different scripts. So for this example, this could just be you installing different tools. You can have like files. These are mainly around, you can copy files from source to destination. So you can copy it from your location, from your local repository to your image. Bearing in mind that there is a problem with Packer that it does allow you to move larger files, but it takes way too long. So you have to be careful as to what size. We usually move around just kilobytes of files. We've seen it struggle with megabytes. So yeah, that's one thing to bear in mind with. And then just to sort of like end with is mainly around sort of waiting to run. So if you're familiar with the Windows one, in this one, let's say it does like a restart. So you can specify a restart as well. And then sort of you can run the sysprep to sort of like create that image, and then sort of like it shuts it down. And once it's done, it creates a VHD and that copies it over to storage account in this scenario here. Now, the reason you want to use Packer is obviously around automation again, because essentially you could create a VM, do everything, and then run this, and then sort of take that VHD out, and then sort of
use the image.
Yeah, exactly. But that's a lot of work, right? Whereas when you do have this, all you're doing is you're specifying several PowerShell scripts mainly, and then you can sort of create that VM on how you want it to be, and then sort of like redeploy it. You can use this in different scenarios.
Yeah, because this is obviously in terms of type of file, it's a JSON file, right?
Yeah, exactly.
But that's what drives Packer, right?
Yes, there is. So Packer has a HCL language as well. So if you're familiar with this, but JSON is probably the easiest way to sort of like get into it.
Fair enough.
They do have a really good documentation around as well to sort of like get up to speed with as well.
Okay, cool. Well, I hope that helped, Darren. We have one other question as well from Jeff. So we talked about VMs quite a lot when we're especially talking about agents and VMs. Are they actually VMs or are they containers?
So now going back to this, so our server product is now installed on. So what we have is we mainly have set of collections of user VMs for every single devs, because we have a server product. They need those VMs because you can't your container does not entirely replicate the environment for them. And to make it easier for them, what we have is everyone has their own VMs. They're actual virtual machines, and then sort of everything is ran on those. It's just because how the product works, right? Whereas on the cloud one, the SaaS one, it's mainly around just different services running in the background. So yeah, that's what they mainly are.
Yeah, I think that makes sense. And then Jeff also asked, can you provide more details on the bringing in-house of the automation testing? It depends what you mean by details. I suppose, what did we not cover? We didn't really cover what the tests run on, as in, what triggers them, because we haven't mentioned Nightwatch, I don't think.
Yeah, so they're essentially, what we have done is we've taken browser stack out. What we've done is then we've got Selenium running in the background, and that's essentially running all of your tests. And what we've done is in here to replicate our requirements, we've the agents that we've created, they're all Windows 10 agents. They have Chrome installed. The tests are basically just running through Chrome driver, being the latest version of Chrome, because then you need to sort of almost be up to speed with that. And then it's just Selenium does that with Nightwatch framework that's running in the background, running different tests. That's how our tests are written, right? So that's based on that around mainly. Yeah, I think that's the most sort of like.
Yeah. I'm hoping, Jeff, that's what you were looking for. Feel free to fire another question. Oh, you have. So you are running on an agent rather than Selenium grid.
Well, so the first sort of, we always have this, had this as like, we don't want to create a lot of overhead for us, because the problem is like, there's always like, you could run a server for Selenium server, and I mean, this is our first instance, so this is what we've created so far, but there's obviously a lot to learn and sort of improve on that. But based on my knowledge, what it was like we were trying to have less overhead for us. We didn't really want it to have like Selenium grid running on a separate VM, because let's say for this one, right? So if I could find if we didn't, so this makes it really easy for us. So if we go into this one, we can actually see the test results in here. So it made sense to just have them in here. And what it does is Selenium is actually running as standalone. So Selenium has a role that you can run Selenium as standalone, meaning that you don't need, different agents to run as hubs, nodes. And then you don't need a separate server that will run as a server. So just take all this out, just keep an agent, less overhead to maintain so far, and then it's just sort of like running in one place. Don't need to worry about it. That's the approach that I first took with this.
Yeah, I mean, we've just basically stripped it down to make it as simplistic as possible.
Just we've always done that since the start, right? Just take everything in one, less overhead, less cost. That's always the best approach, hopefully.
For us, not the only approach.
Not the only approach, yeah.
Yes, so Jeff, yes. Testing only across Chrome rather than multiple browsers, yeah. I mean, that was actually one of the reasons that we moved away from Browser Stack as well, because Browser Stack's a great way to test across, mobile devices, lots of different browsers. But actually our core end-to-end testing focuses on Chrome. So again, that was another reason why we weren't fully utilizing the Browser Stack's capabilities.
I mean, these days most browsers rely on Chromium, right? So
yeah, I mean, I suppose, yeah. I don't know what the percentages are, but they're pretty high.
Yeah, exactly.
Yeah, hope that helped. No problem, Jeff. Thanks for the questions. Okay, anything else? Any other questions coming in? Otherwise, I think we've covered everything we wanted to talk about.
Yep.
Fantastic. Well, thank you, Tim. Thank you, Shaz, for such a fantastic presentation and demo. I've truly enjoyed that. I finally learned how our product works. So that was really cool for me as well. But thank you.
No problem. You're welcome.
No worries. So I'm going to take again from here. I'm going to share my slides again. So that was a fantastic presentation by Tim and Shaz. And then just to wrap things up, so for the next meetup, it's going to be in December. We won't have a meetup in November. More details about December will be coming up. All I can tell is that it's most likely going to be another fantastic talk from SquaredUp speaker. So stay tuned in. And finally, thank you so much for attending a meetup. If anyone wants to hang around, we will be still around, and then for socializing. And then, as Alicia mentioned at the beginning, if anyone feeling like they've have a burning desire to share their knowledge with the rest of the world, we always like to be a platform for those kind of speakers. So please do register your interest at the link provided or sessionize. And with that, I think we're done for today. Thank you so much for attending.